In this section, we are going to discuss about memory read and memory write machine cycles of 8085. First of all, let's see memory read machine cycle. What do you mean by memory read? Memory read is the process of taking data which is available in external memory into inside microprocessor. The memory read machine cycle is executed by the processor to read a data byte from memory. In order to complete one memory read machine cycle, usually it requires 3 T states. So this is memory read machine cycles of 8085. So in order to complete memory read machine cycle, it requires 3 T states, T1, T2 and T3. Let's see what are the control signal and how these signals are operated. So first of all, we need to draw clock signal like this. Then during T state 1, program counter places address of the memory where the data is available into address bus and AD bus. That is, address bus carries higher order address during T1, T2 and T3. Low order address is handled by AD bus during T1 only. But MUP need low order address during second and third clock cycle also. So by means of an external D latch along with ALE signal, address latch enabled signal, it is possible to make available this low order address during second and third clock cycle also. So in order to make that one, ALE signal goes high during first cycles of every machine cycles. Then another important signals are status signal, that is IO by M bar signal, and S0, S1. This IO by M bar indicate whether the relation is with memory or IO devices. So here the address of the device is for memory related operation, therefore IO by M bar is equal to 0. And corresponding to read operation, S1 is equal to 1 and S0 is equal to 0. As during first clock cycle, by means of ALE and external hardware, this low order address is available as the output of external hardware. This data bus is now free. Whenever RD bar signal goes low during second clock cycle, whatever be the content of memory specified by this address is moved into data bus AD bus. This data bus is of 8-bit width. So whenever RD bar signal goes low during second clock cycle, data from this location is moved into AD bus. Then whenever RD bar signal goes high during third clock cycle, the data which is now available in AD bus is transferred to the specified registers inside MUP. So in this way you can draw the memory read machine cycle timing diagram. Next one is memory write machine cycles of 8085. What is memory write? Here the data is available inside MUP that we need to transfer into memory location specified in the instruction. The memory write machine cycle is executed by the processor to write a data byte in a memory location. In order to complete this process, again it will take 3 T states, and please note this status signal. This is the memory write machine cycle of 8085. Here we need clock signal just like earlier case. During first clock cycle, program counter places address of this memory location in address bus and address data bus. Address bus A8 to A15 carries higher order address. AD bus carries low order address. In order to make it available this low order address during second and third clock cycle, we need an ALE signal and external hardware. So ALE signal goes high and then goes low during first clock cycle of every machine cycle. Then this is the status signal. Here the data is to be moved into memory location. So this address is related to memory address. So IO by M bar is 0 and S1 is 0 and S0 is 1 for memory write machine cycle. And as this low order address is available as the output of external hardware, this is free, AD bus is free during T2 and T3. So whenever WR bar signal goes low during second clock cycle, the data which is available in mu P is transferred into data bus. Then whenever WR bar signal goes high during third clock cycle, this data which is available now in AD bus is transferred to that memory location. This we can draw in this way.